What was Oumuamua and what was the controversy around it?
I mean, it was a fascinating discovery. I think it was 2017 or 2018 it was discovered. And it was the first example of an asteroid that was detected whose orbital parameters were such that it could not be bound to the sun. It was essentially moving too fast through the solar system to possibly be a stable orbiting object, which means it was an interstellar object. So it came from another star system, which was a fascinating example of what was possible. I don't think anybody expected that. I think we knew that interstellar asteroids probably existed. And when we did our calculations as to how often we expected them to come through the solar system, it was like a factor of 100 less than what would be necessary for us to detect it. So the fact we even saw it was very surprising. It meant that there was way more of this stuff than we anticipated. And that's actually one of the reasons Avi leveraged to suggest this could be artificial, right? Because if you believe the natural rate, then this shouldn't have happened. So maybe someone sent it here deliberately or something. I think more realistically, we probably just made an error in those initial calculations, and there's just a lot more scattering that actually happens in planetary systems than we expected. It also seemed to have a pretty strange shape. So we can tell the shape by watching how much light reflects off it. So light reflects off it isn't just a constant. It obviously gradually dims as the object moves away from us. That's when we detect it. We detect it on the way out. We didn't see it on the way in. We detected it once it was already on the way out. I think it was in Pan-STARRS, and a telescope survey detected it. And by monitoring the brightness, you can see it going up and down, up and down, up and down. So it's actually spinning. And it's not clearly a sphere, because if it was a sphere and it was homogeneous, it would spin, sure, but there would be no differences in brightness. This thing had huge differences in brightness. I think it was like a 10-to-1 brightness change. So that suggested it had a very high aspect ratio. So it was either like a pancake, like almost a UFO saucer-shaped thing, or it could be like a cigar shape. Those are two possible shapes that people concluded were compatible. And neither of those are really anticipated. And again, in the solar system, there are very rare examples of asteroids which have extreme shapes like that, but they're definitely not par for the course. So it's a little bit surprising that the first interstellar asteroid would take on that shape. And then finally, the other weird anomaly about it was that it didn't seem to be decelerating at the rate it should do as it moved away from the sun. Obviously, the sun's kind of pulling it back with gravity, trying to slow it down as it leaves. But it actually seemed to be decelerating less than it should. So in other words, it was almost as if it had a little propulsion system on board that was pushing it along. But a very, very, very tiny propulsion system. It was a minuscule difference, but a significant difference. And sometimes comets and asteroids do that. It's actually been seen many times. And that's because they outgas. So as they swing past the sun, often they have lots of ice on the surface, and that ice melts and sublimates, and it forms like a gas jet. So that's like a little propulsion that powers it along. So it's not surprising that could happen. But I guess what was surprising is that we didn't see any such jet coming off it. So if it was being propulsed that way, we might expect to see the gas coming off it, but we didn't detect any gas coming off it. However, it's not impossible that there was gas coming off it, just not the gas we expected. So when you look for this gas, you have to use telescopes with a certain wavelength sensitivity, and we mostly tuned it to sort of the usual suspects of what gas could be coming off it. But there's some gases like carbon monoxide, I think, which are less commonly released from these asteroids, and we didn't check for that. So it is possible it was just a gas that we didn't expect that was being outgassed. And I think that's kind of the end of the story in terms of our observations. And so Avi stepped in and said, all of these anomalies maybe are consistent with it being a light sail. And I would interpret what Avi said to be that this isn't definitely a light sail, but there's just this possibility. And I think that's not an irrational thing to say. But it does kind of also suffer from the God of the gaps aspect of aliens that we talked about earlier, how aliens can explain everything. So whenever you come across something you've never seen before for the first time, like a pulsar, you've never seen such a thing, it's really tempting to say aliens did that. And it works. It's a pretty good, efficient hypothesis. But it's often the case, as we've learned historically, that our knowledge has just not yet caught up to the current state of the art. So yeah, I tend to lean on the idea that this is something else. And certainly there are other hypotheses, natural hypotheses, which kind of work. But I know Avi has issues with some of those alternatives as being somewhat implausible and contrived as well. So it's a mystery. And I think the most interesting thing about Oumuamua is that it should not be the only one. We have new telescopes coming online just this year called Vera Rubin, which should detect about 10 of these every year. So we should get lots of these things. And once we start seeing lots of them, we can really understand what's going on with the population, and we could even intercept it. So there's a European proposal to build an interceptor mission, which would just sit in the solar system waiting. And as soon as we detect one of these things, it turns its engines on, goes full blast, and tries to catch up, land on the thing, and then send images, sample the surface, do mass spectrometry, and then we will know exactly what it is. So I think that's a really exciting possibility. It will be our first, rather than landing on another planet, an exoplanet like Alpha Centauri, and taking samples of the surface, why do that when the material is coming into our solar system? We can do it kind of way cheaper. So it's an opportunity to learn what exoplanets are made out of kind of the cheapest way possible. So I think that's a very exciting prospect.
Yeah, no, that's very exciting. One question, though, that this discussion raises when coupled with the discussion we just had about possible propulsion methods is, so the most successful of the possibilities was this idea that we would have a light sail that would propel this very, very tiny object. But Oumuamua is significantly larger, and if it were just a fragment of a light sail, then presumably it would be much, much larger than that. Mm-hmm. So is a light sail a practical method, even if not technologically feasible, to propel something very large?
It depends what you mean by large. If you mean in terms of its actual physical size, sure, it can be as large as you want it to be.
I mean massive.
Yeah, if you want mass, which I guess is what you mean, then it's not ideal at all, because really the key number is what we call the areal density. So that's the mass per unit area. And you want that number to be tiny, of order of sort of 0.1 grams per meter cubed, which is just like a few atoms thick is what we're talking about here. So if you take like aluminium or zinc or gold, sometimes people talk about these materials as possible candidates, you need sort of like 20, 30 atoms thick of that to achieve that density. So extremely thin, and you really can't afford any extra wasted mass on that thing whatsoever. So we don't know the mass of Oumuamua. So no one measured the mass of Oumuamua, so we don't know what its true mass would be, but we know its proportions. I think it's of order of sort of 100 meters across. So there's no reason why you couldn't have a 100-meter light sail. But I would say, there's some things about being a light sail which look a little inconsistent. The surface is not shiny. I mean, a light sail should be shiny. The surface is not particularly shiny on this thing. It looks, very degraded over time. So maybe it's once upon a time was a light sail and now is covered in dust or something. But it's also tumbling, which is kind of odd. It doesn't have it's certainly not an actively controlled light sail. I think we could say that with absolute certainty, because the thing's just tumbling around in space. It's not pointing its sail at the sun all the time like it should be. So I'm a little bit skeptical that it truly is a light sail given those properties. But I think the exciting thing is it's a testable hypothesis, right? As I said, so we should have more of these things emerge in the future, in future surveys, and we even could land on one of these objects in the future. So whatever your opinion, the exciting thing is it's testable science, and that's science at its best.